Hello, lovely viewers. Welcome back to my YouTube channel. In this video, we will take a look at a 4x4 system. We are asked to find the exponential of the matrix. So, we start by finding our eigenvalues. So the first thing you have to do is to find our eigenvalues. We then categorize the eigenvalues into stable subspace, unstable subspace, and center subspace. So stable subspace, unstable subspace, and center subspace. The next thing we do is to find our eigenvectors. Then next we find our matrix P and its inverse. And then lastly, we find the exponential of a matrix given by P e to the power d P inverse. To find our eigenvalues, we find the polynomial determinant of a minus lambda I, and when we equate our polynomial to 0, it implies we are equating the determinant of a minus lambda I to be equal to 0. So our first step would be to find our eigenvalues. So we have the determinant of a minus lambda I, which is, so we have 2 minus lambda, 0, minus 1, 1. We have 1 minus lambda, minus 1, 1, 1 minus 3, 2 minus lambda, minus 1, 0 minus 3, 2, and minus 1 minus lambda. It is better to find the determinant of the matrix 10 by 10. We first write down the components. So we have 2 minus lambda, all in bracket. We take a 3 by 3 matrix. We have 1 minus lambda, minus 3, then minus 1, 2 minus lambda, 2, 1, minus 1, minus 1 minus lambda. We have minus 0 times the determinant, which we have 1, 1, 0, minus 1, 2 minus lambda, 2, 1 minus 1 minus 1 minus lambda. And we have plus minus 1, multiplying the determinant 1, 1, 0, 1 minus lambda, minus 3, and we have 1 minus 1 minus 1 minus lambda. Finally, we have minus 1, multiplying the determinant 1, 1, 0, 1 minus lambda, minus 3, minus 1, 2 minus lambda, 2. We see that this term will be 0, and finding the determinant 10 by 10 would be a much efficient way. So we have the first term to be 2 minus lambda, multiplying the determinant 1 minus lambda, minus 3, minus 1, 2 minus lambda, 2, 1 minus 1 minus 1 minus lambda. So this term gives us 2 minus lambda, all in bracket. Then we have a big bracket. We have 1 minus lambda, all in bracket. Bracket 2 minus lambda, multiplying minus 1 minus lambda, minus 2 times minus 1. You have minus, it's bracket minus 1 minus 3, multiplying minus 1 minus lambda, minus 3 minus lambda, which gives us minus 3, plus 1 into bracket minus 3 times 2 minus 3 times 2 minus lambda. Because of this term, and this term, it is better not to expand the bracket, but keep them as they are. So we have the expression 2 minus lambda, big bracket, we have 1 minus lambda, 2 minus lambda, minus 1 minus lambda, then minus, it gives us plus 2, so we have plus 2 into brackets 1 minus lambda, and we have plus 1, multiplying the expression minus 3 into brackets minus 1 minus lambda, then we have minus 3. Plus into brackets minus 6 and plus 3 into bracket 2 minus lambda. And we close our big bracket. So we have 2 minus lambda. We group like them. We have 1 minus lambda, 2 minus lambda, minus 1 minus lambda, plus 2 minus 2 lambda, then we have minus 3 into brackets minus 1 minus lambda, minus 3 minus 6 plus 3 into bracket 2 minus lambda. Two minus lambda, then 2 minus lambda again. We have 1 minus lambda multiplied by minus 1 minus lambda plus 3. 2 minus 9 gives us minus 7. We have minus 2 lambda minus 3 into bracket minus 1 minus lambda, converting as 1 plus lambda, and the minus makes this plus. We close our bracket. So now we have everything we need. This is equal to 2 minus lambda so we have 2 minus lambda, and expanding everything here, we have minus into brackets 1 minus lambda, 1 plus lambda, plus 3 minus 7 minus 2 lambda plus 3 plus 3 lambda. So you have 2 minus lambda, 2 minus lambda into bracket, you have minus into bracket 1 squared minus lambda squared plus 3 minus 7 plus 3 gives us minus 4, and 2 minus 2 lambda plus 3 lambda gives us plus lambda. Okay, there's a bracket here, there's a bracket here. Okay, so you have 2 minus lambda, big bracket, we have 2 minus lambda again. This gives us minus 1 plus lambda squared plus 3 minus 4 plus lambda. is equal to 2 minus lambda, and 2 minus lambda to bracket 3 minus 1 is 2 plus lambda squared, and minus 4 plus lambda. So 2 minus lambda. Expanding this, we have 4 plus 2 lambda squared minus 2 lambda minus lambda cubed minus 4 plus lambda. And we have 2 minus lambda into bracket. We have 4 minus 4 minus lambda cubed plus 2 lambda squared minus lambda. Factorizing minus lambda out, we have minus lambda, 2 minus lambda, and then this gives us lambda squared minus 2 lambda plus 1. And this gives us minus lambda, 2 minus lambda. And we have lambda minus 1 all squared. So for the next term, we have minus 1 110 1 minus lambda minus 3 minus 3 1 minus 1 minus 1 minus lambda. So expanding this, we have minus 1. So we have 1 multiplying minus 3 into bracket minus 1 minus lambda minus 3 times minus 1, which is 3, and we have minus 1 minus lambda into bracket 1 times minus 1 minus lambda minus 0, and we have plus 1 to bracket minus 3 and minus 0. We close our bracket, so we have minus 1 into bracket minus 3 to bracket minus 1 minus lambda minus 3 minus 1 minus lambda into bracket minus 1 minus lambda minus 3. Multiplying through by negative 1, we have 3 into bracket minus 1 minus lambda plus 3 plus 1 minus lambda minus 1 minus lambda plus 3. So factorizing minus 1 minus lambda minus 1 minus lambda into bracket 3 1 minus lambda, we have plus 6. Okay, this gives us minus 1 minus lambda multiplying 4 minus lambda plus 6. This is equal to minus 4 plus lambda minus 4 lambda plus lambda squared plus 6. Now we have lambda squared minus 3 lambda plus 2. Next, we find our last expression, which is minus 1 minus 1 1, 1, 0. 1 minus lambda minus 3 minus 3. Minus 1, 2 minus lambda 2. So we have minus 1 multiplying the expression 1 into bracket minus 3 times 2 minus 3 times 2 minus lambda minus 1 minus lambda into bracket 1 times 2, which is 2, and 0 times 2 minus lambda, which is 0, plus minus 1 into bracket minus 3. The other part is 0. I close a bracket. This is minus 1. There's a bracket here. So we have minus 6 plus 3 into bracket 2 minus lambda and minus 2 into bracket 1 minus lambda plus 3. Close our bracket. So multiplying through by minus 1, we have 6 minus 3 into bracket 2 minus lambda and plus 2 into bracket 1 minus lambda minus 3. 6 minus 3 gives us 3. We have minus 6 plus 3 lambda. We have plus 2 minus 2 lambda. This is equal to lambda minus 1. Okay, so we combine all the terms. So the determinant of A minus lambda I is equal to, we have minus lambda 2 minus lambda minus 1 squared. The next thing we have lambda squared. So we have plus lambda squared minus 3 lambda plus 2. We have plus lambda minus 1. And this is equal to, make lambda minus 1 square the subject. We have lambda squared minus 2 lambda. Then we have plus lambda squared minus 2 lambda plus 1. This is equal to lambda minus 1 all squared into bracket lambda squared minus 2 lambda plus lambda minus 1 all squared. So we have lambda minus 1 all squared into bracket lambda squared minus 2 lambda plus 1. And now this gives us lambda minus 1 all squared and lambda minus 1 all squared. So that in all, this gives us lambda minus 1 to the power 4. So we have that the determinant of A minus lambda I is lambda minus 1 to the power 4. So if lambda minus 1 is equal to 0, it implies that lambda is equal to 1. And the multiplicity is 4. So the multiplicity of lambda is what? 4. So by not expanding the bracket and keeping them in their confined manner, and also solving it term by term, has made it possible for us to get this answer very simply. And now lambda equals 1 is positive, so lambda is greater than 0. for all values of lambda. So what do we see? That this is what the system is unstable, or we only have the unstable subspace for this system. So the system is unstable at the origin. So we write our unstable subspace as a span of V1, V2, V3, and V4. So all we need to do is find the values of V1, V2, V3, V4 and substitute them. This will give us the unstable subspace for our system. So the next step is to find the eigenvectors. Since the system consists of repeated eigenvalues, there is no need to find our P and P inverse, because our P will be equal to our P inverse, which is equal to the standard basis, which is 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. So there's no need to find our P and P inverse. So the exponential of our matrix, which is given by P e to the power d P inverse, will just be equal to e to the power d. But in this case, our e to the power a is given by e to the power s plus n. So now we have to find e to the power s and e to the power n. So you have to find our S matrix and our N matrix. So for our S matrix, it is given by P, D, P inverse, which is the same as our D, because our P is the same as our P inverse. So our S is equal to D. So for us to find our N, we have to subtract S from A, which is given by, I will take 2, 0, minus 1, 1, 1, 1, minus 1, 1, and 1 minus 3, 2 minus 1, and 0 minus 3, 2 minus 1, minus 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, which will give us 2 minus 1 is 1. We have 0 minus 1, 1. Then we have 1. 1 minus 1 is 0. And we have minus 1, 1. 1 minus 3. 1 minus 1. And 0 minus 3. 2. Minus 1 minus 1 is minus 2. So we find our n squared, which is 1, 1, 1, 0, 0, 0, minus 3, minus 3, minus 1, minus 1, 1, 2, and 1, 1, minus 1, minus 2. We're going to square this. Minus 3, minus 3, minus 1, minus 1, 1, 2, 1, 1, minus 1, minus 2. So this is given. We have 1 plus 0 minus 1 plus 0. Next we have 0 plus 0 plus 3 minus 3. So 3 minus 3. Next we have minus 1 plus 0 minus 1 plus 2. And again we have 1 plus 0 plus 1 minus 2. For the next line, we have 1 plus 0 minus 1 plus 0. Again, we have 0 plus 0 plus 3 minus 3. And again, we have minus 1 plus 2, and 1 plus 1 minus 2. Next, we have 1 minus 3 plus 1 plus 0. And we have 0 plus 0 minus 3 plus 3. Minus 1 plus 3 plus 1 minus 2. We have 1 minus 3 minus 1 plus 4. We have 0 minus 3 plus 2 plus 0. So 0 plus 0 minus 6 plus 6. When you have 0 plus 3 plus 2 minus 4. 0 minus 3 minus 2 plus 4. So this n squared will give us, so n squared will be, we have 0, 0, 0, 0, and 0, 0, 0, 0. We have minus 1, 0, 1, 1, minus 1, 0, 1, minus 1. This is supposed to be 2. So we have minus 1, minus 1. So we find n cubed 0, 0, 0, 0, 0, 0, 0, 0, minus 1, 0, 1, minus 1, minus 1, 0, 1, minus 1. You have 1, 1, 1, 0, 0, 0, minus 3, minus 3, minus 1, minus 1, 1, 2, 1, 1, minus 1, minus 2. The first two rows are zeros. So you focus on the second two rows. We have minus 1 plus 0 plus 1 plus 0. 0 plus 0 minus 3 plus 3. We have 1 plus 1 minus 2. And you have minus 1 plus 2. So the same thing will be for the next row. So you have minus 1 plus 1, minus 3 plus 3, 1 plus 1 minus 2, minus 1 plus 2. So n cubed will just be zeros. So now we can write the exponential of a matrix, which is given by e to the power s, e to the power n, e to the power s, which is e to the power 1, 0, 0, 0, 0, e to the power 1, 0, 0, 0, 0, e to the power 1, 0, 0, 0, 0, e to the power 1, multiplied by e to the power n, where e to the power n is given by I plus n squared over 2 factorial plus n cubed over 3 factorial. So substituting, we'll have I plus n squared over 2 factorial, which is 2. N cubed is 0, so we stop there. So e to the power a is given by e to the power 1, 0, 0, 0, 0, e to the power 1, 0, 0, 0, 0, e to the power 1, 0, 0, 0, 0, e to the power 1. The other matrix is given by 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. plus n, where n is given by 1, 1, 1, 0, 0, 0, minus 3, minus 3, and minus 1, minus 1, 1, 2, and 1, 1, minus 1, minus 2. And n squared is given by 0, 0, 0, 0. We have 0, 0, 0, 0, 0, 0, 0, 0, minus 1, 0, 1, minus 1, minus 1, 0, 1, minus 1. This is multiplied by half, so e to the power a is e0, 0, 0, 0, e0, 0, 0, 0, e0, 0, 0, 0, e, multiplied by, we have 2, 0, minus 1, 1, 1, 1, minus 1, 1, 1, minus 3, 2, minus 1, and 0, minus 3, 2, minus 1, plus we have 0, 0, 0, 0, 0, 0, 0, 0, minus 1 over 2, 0, 1 over 2, minus 1 over 2, minus 1 over 2, 0, 1 over 2, minus 1 over 2. So e to the power a will give us e0, 0, 0, 0, 0, e0, 0, 0, 0, e0, 0, 0, 0, e. You have 2, 0, minus 1, 1, 1, 1, minus 1, 1. You have half, minus 3, 5 over 2, minus 3 over 2, minus 1 over 2, minus 3, 5 over 2, minus 3 over 2. That will give you the exponential of the matrix. So the exponential of the matrix. So after simplifying, we will then have our final solution, which will be the exponential of the matrix. And that will be all for this video. See you in the next video.